Hi, we're MEDIBlog. My name is Joyo Kang.
And I'm Ahmed Alusni.
Today we'll be exploring high blood pressure.
This is also known as hypertension, and we're going to investigate how salt affects this through a simple experiment you can even try at home.
And hopefully this experiment will demonstrate how a high salt diet is very, very bad for you. All you need for this experiment are weighing scales, Viscount tubes, two 250ml beakers, sodium chloride, also known as common salt, and food colouring. If you have a pipette, that would be quite useful as well. The solution in this Viscount tube and this beaker have no salt in them. We dip this so that we put food colouring in them so that they'll demonstrate the movement of water. For example, this solution, when put into this salt solution here, it will hopefully move out into the solution in the beaker. This is because the concentration of salt is higher in the beaker than the Viscount tube, which means the concentration of water is higher inside the Viscount tube than outside of it. Therefore, the water will move out through the process of osmosis. And likewise for this one here, the concentration of water is higher in this solution here than in the solution in the Viscount tube. Therefore, water will move in along with the dye, meaning hopefully by the end of this experiment, this Viscount tube will be red and this solution in the beaker will be red as well. This following PowerPoint will walk you through the knowledge behind the experiment.
Okay, so this is an introduction to the theory behind it. So salt is vital to keeping water in our bodies because it affects the concentration in the bodies and in the organs within the bodies. So for water retention to work, your kidneys need to hold on to more water from the blood when it absorbs it. If your kidney takes in more water, because of higher salt levels in the blood, then it can lead to higher blood pressure and can put strains on organisms such as the kidneys, arteries, heart and brain.
The kidneys. Their main job is to filter toxins from the blood. They also remove excess fluids which is stored in the bladder and expelled from the body as you urine. As you consume more salt, the balance of sodium and potassium in your kidneys and your blood becomes disrupted. This increases your blood pressure, putting extra strain on your kidney. This eventually will lead to kidney failure and you may have to have your kidneys removed and transplanted. This is treated with diuretic medication which helps remove excess fluid from your system.
The same principle is similar with arteries. So an increase in salt increases the blood pressure, and this can lead to strain on the arteries. And as the arteries strain, the muscles in the arteries want to try and overcome the strain by becoming thicker and stronger. But this in fact worsens the problem because the arteries actually become narrower, so the blood pressure increases. Eventually the arteries do burst and can clog up entirely, which can affect the organs receiving blood from these arteries and can lead to organ failures in areas such as the brain or the heart, as we will explore later in the video.
This would be most fatal in the arteries leading to the heart. Again, more salt equals more blood pressure equals more strain on the arteries. If the arteries leading to the heart block up, it may lead to coronary arrest. Well, that will be in the more extreme cases. It will first start off with sharp pains, leading up to more and more damage to the heart, until it fails entirely.
Okay, so the brain is also an organ which is heavily affected by strain on arteries, because the arteries leading to the brain are really important in our bodily functions and controlling the body in its jobs. So if arteries fail to reach some parts of the brain, it can lead to dementia, which is memory loss. We have split up the experiment into 4 pictures, which will show the effects of blood pressure by salt. So the first picture is right at the beginning of the experiment. Second picture shows where the water will move in the experiment. by osmosis. The third picture shows the colour changes from the right at the start, and then the fourth picture shows the final result with differences in water height in the test tube and the viscid tubes. Yoel will explain each step now.
Okay, step number one. When we started the experiment, the salt solution in this vacuum tube was higher than outside. Therefore, the water concentration was higher outside the vacuum tube, and it moved into the vacuum tube, pulling along with it the dyes, as represented by these arrows here. The second test tube, we put the water inside the vacuum tube, along with the dye, and we put the salt solution outside of it. Therefore, the water concentration was higher inside the vacuum tube than outside in the beaker, and so therefore, through osmosis, it moved out, shown by these arrows here. And therefore, as the dye moves in with the water, moves with the water, we would expect a colour change very similar to this, as shown by here, as by these vacuum tubes and these beakers. You can see that all of them contain the red dye, that we put in only two of.
As you can see from the first picture, only the beaker in one and the viscid tube in the other had red dye, but now all four have red dye, like in this picture number 3. Yeah?
Thank you. And the final result we would expect to look something like this. Water moves in, and therefore the water volume inside the vacuum tube increases. It causes the vacuum tube, therefore, to swell up. In here, the water moves out of the vacuum tube, and therefore we expect the volume to reduce and the vacuum tube to shrink.